Hi, Assalamualaikum. This is our final project, which is sentiment analysis in producing a classifier model of mobile game. Okay,
In
this
our
is
team,
our
there
teammate.
are three of us.
Firstly is
First,
Ahmad
Ahmad
Imran
Imran
Hakim bin
Hakim bin
Ismail.
Ismail,
Secondly is Ishadi Daniel Haikal Shah bin Ismazlan. And
2029478.
lastly, Ahmad Afif
Second,
Daniel bin Rosli.
Ahmad Afif Daniel bin Rosli, two zero
Okay,
two zero
this is
eight three
our
four
teammate.
nine one two. And third,
Firstly is Ahmad
Eshadik Daniel
Imran Hakim
Haikal
bin
Shah
Ismail.
bin
Secondly is
Esmazlan,
Ishadi Daniel
two
Haikal
zero
Shah
two zero
bin
six
Ismazlan.
zero
And
five
lastly, Ahmad Afif
three
Daniel
zero
bin
two.
Rosli.
Introduction. Okay, Assalamualaikum warahmatullahi wabarakatuh. So for our project background, which is mobile game. The popularization of mobile games began as early as 1997 with the introduction of Snake preloaded on Nokia features phone, demonstrating the practicality of games on this device. Several mobile device manufacturers included preloaded games in the wake of Snake's success. In 1999, the introduction of the iMode service in Japan allowed a wide variety of more advanced mobile games to be downloaded onto smartphones. Though the service was largely limited to Japan, most initial games were published as a premium, which is pay once titles, but the addition of in-app purchase in October to 2009 allowed games to try other models, with notable successes Angry Birds and Cut the Rope using a combination of free to try and ad-supported games. Many of the most successful games have hundreds of millions of players and have annual revenues exceeding $100 million a year, with the top games breaking $1 billion. More recent trends have included hyper-casual games such as Crossy Road and location-based games like Pokemon Go. So for the problem statement, we have two problem statement, which is reviews provide a variety of comments and monitoring the uses of mobile games. So here the objective we solve the problem statement. For the first objective, we deciding on the most effective model to estimate how a product will be perceived. And second one, we develop a classifier model that can determine if the data feedback is good or negative. Okay, this is our literature review for mobile game, which examining the usage of games in higher education has drawn more attention. Recovery included in this area instructional video games from Ankaya and Karamet 2009. Digital games based learning DGBL from Young 2012 and practical video games from Van Rosel and Van Masrai Ide 2011. The term games is also occasionally expanded by academics to cover interactive exercise. From Muller 2003, video games from Baidis and Irwin 2010, or even next generation video games from Bouts 2008. Computers and gaming consoles are among the technical platform that use digital game code in relation to web-based games, which is from Salen and Zimmerman 2004. Mobile phones and other gaming devices may run them using a web browser from Willoughby 2008. Okay, so for the second literature review from PUBG, which is Yonding 2018 paper mainly studies operational model of the famous computer games, which is PUBG. Be aimed at human beings in the game or human being regarded as intelligent robots, including the influence of objective factors and subjective factors on the game results. Linear programming model is established for the various factors and the game result using Excel software realized in different situations the relationship between various factors and the result of game problem solving plotting table. So basically PUBG is a mobile game which the long name is Player Unknown Battleground. Okay, so for the sentiment analysis, there are about 3.5 billion active social media users, accounting for over half of the world's population. Every minute, users write over 500 1,000 tweets and post 500,000 Facebook comments, and many of these communication offer vital commercial data about how consumers feel about playing mobile games. Sentiment analysis enable businesses to mine this data and extract the emotions that underpin social media conversation, allowing them to understand how and why people are talking about a mobile game.
Let's move on
Methodology.
to methodology. Business understanding. To conduct the research, the data was fetched from Twitter. Two data sets have been taken. One is of 600 tweets and other is of 400 tweets. This data has been taken with the help of scraper written in the Python. This data set has remarked on mobile game as number of people on Twitter give feedback on mobile game. The data set has been prepared by classify the tweet into positive and negative remark. Data understanding. The main aim of this research is to analyze the accuracy of sentiment polarity using naive Bayes and decision tree technique. Also, comparison between these techniques is observed to find out the best performing one. Data preparation. Research and collect data of a total of 1,000 data from Twitter reviews regarding our research, which is mobile game, namely 600 data for training and 400 for testing. After that, we export the data into RapidMiner so we can test their polarity, whether the percentage is more positive or negative. An experiment has been performed in RapidMiner to can get the accuracy of sentiment polarity using naive Bayes and decision tree technique. Also, comparison between these techniques can find out the best performing one. We go to the data modeling. Before we start RapidMiner, we will do two things. The first, we need to find polarity data, and the second is to find percentage accuracy. So we will use these two dataset, which are training and testing. First dataset is training. First, we need to create a connection. Press the create connection button as in the picture. The connection type will be displayed soon, so we need to fit it in. We choose Twitter for connection type, and then choose local repository for repository. And last, we need to give a name for our connection, so we put the name Twitter mobile game. After finishing, press OK, and then edit connection will come out. So click the button in the access token section. After we press the button in the access token section, authenticate RapidMiner via auth will come out. We need to press show URL instead as shown in the picture to get the link. And then the link needs to be copied and pasted into Google for us to authorize the app. After we press the authorize app button, we will be given a code to copy and paste near the copy code section, and then we press OK. Once finished, we need to press the test connection button to make sure the connection exists, and then we press OK to make sure the connection is ready to use. Next step, we need to find raw data. First, we need to search Twitter in the operator section and then drag it to the attachment section of the process. And then in the parameter section, we need to select the repository, fill in the connection entry section by selecting the connection we want to use, which is Twitter mobile game. Fill in the query and also the language. Once done, we continue the process. We drag right Excel from the operator and then press the right Excel box, and in the parameter section, press the button in the Excel file section. Later, open file will come out, and then we select the desktop to save the data. After getting the text data, we need to find the polarity. We drag the read Excel box from the operator and then press the red Excel box, edit in the parameter section, press file in the Excel file section, and then select the data we have saved earlier, which is mobile game. Once ready, we drag the nominal box to text, press the box and edit in the parameter section. Select subset in the attribute filter type section and press select attribute. Add the selected attribute with text and press OK. After that, we use abstract sentiment, edit in the parameter section, select value for the model and select text for the text attribute. After that, we drag right Excel from the operator to the process attachment. Press the file button in the Excel file section and save the data in the desktop section and press OK. After completing the polarity finding process, add all the operators from read Excel operator to write Excel and add them to rest, and then run the process and will show the data. So we open Excel and edit the Excel section. Remove all column except the text column, negative and positive as in the diagram. And then we search for polarity. We press the FX button in the Excel section to get polarity. We enter the formula. After getting the polarity, we remove the negative and positive column so that we can get the text and also the polarity only. After getting the polarity, we move to the process part to get the percentage accuracy. We need to save the one earlier. And now we open the new process attachment. The output data we saved earlier. We drag to the process attachment. We select the data that we have searched for polarity here in the repository entry section. We have data that is output mobile game, and then we use the set role operator. Edit in the set role parameter section. We select polarity for the attribute name and label for the target role, and then we add operators. We use the nominal operator to text. Select a subset for attribute filter type. Next, we add an operator. We use the operator process document from data. In the parameter process document from data section, we use TDIDF for vector creation. In this section as well, we need to double click, and in the process document from this data, we use tokenize stem pointer, filter stop word English and transform cases. After that, we add the cross validation operator. In this operator, we double click and then it is divided into two process attachment boxes. One training and the other is testing. So in this part of the training, we will put the decision tree model. In the testing section, we put operator apply model and performance. After finishing everything, we are running the process. We will get a percentage accuracy for the decision tree model of 94.33%. We need two different percentage accuracy model, so we need to change the model in the operator part of the model. In the operator part of the decision tree model, we change it to the Bayesian model, and we run the process, and we will get the percentage accuracy for the Bayesian model, which is a total of 84.50%. So the process for dataset training is complete.
Data modeling, testing dataset.
Okay, hi. First, we need to create connection. Press the create connection button as in the picture. The connection tab will be displayed soon. So we need to fill in it. We choose Twitter for connection type, and then choose local repository for repository, and last we need to give name for our connection. So we put the name Twitter mobile game. After finish, press OK, and then edit connection will be come out. So click the button in the access token section. After we press the button in the access token section, authenticate repeat manner via out8 will come out. And we need to press show your ad instead as shown in the picture to get link, and then the link need to be copied and pasted into the Google for us to authorize the ad. Okay, after we press the authorize ad button, we will be given a code to copy and paste near the copy code section, and then we press OK. Once finished, we need to press the test connection button to make sure the connection exists, and then we press OK to make sure the connection is ready to use. Okay, in the next step, we need to find a raw data. First, we need to search the Twitter in the operator section, and then drag it to the attachment section of the process. And then in the parameter section, we need to select the repository, fill the connection entry section by selecting the connection we want to use, which is a Twitter mobile game. Fill in the query and also the language. Okay, once done, we continue the process. We drag right Excel from the operator and then press the right Excel box. And in the parameter section, press the button in the Excel file section. Later, open the file will come out. And then we select the desktop to save the data. Okay, once finished, we press the run button at the top. Repeat manner, we show the result. From the final result, automatic will also save in Excel. So we open Excel and delete all column except the text column. We need the text for the projects. After getting the text data, we need to find the polarity. We drag the read Excel box from the operator and then press the read Excel box, edit in the parameter section, press file in the Excel file section, and then select the data we have saved early, which is mobile game. Once ready, we drag the nominal box to text, press the box and edit the parameter section. Then subset in the attribute filter type section and press select attribute. Add the selected attribute with text and press OK. After that, we use the extract sentiment edit in the parameter section. Select weather for the model and select text for the text in attribute. After that, we drag right Excel from the operator to the process attachment. Press the file button in the Excel file section and save the data in the desktop section. And we press OK. After completing the polarity find the process, add all the operator from read Excel operator to write Excel and add them to rest. And then run the process and we show the data. So we open the Excel and edit the Excel section. Remove all column except the text column, negative and positive as in a diagram. And then we search for polarity. We press the first button in the Excel section to get polarity. We enter the formula. After getting the polarity, we remove the negative and positive column so that we can get the text and also the polarity only. After getting the polarity, we move the process part to get the percentage accuracy. We need to save the one early. And now we open the new process attachment with the output data we save early. We drag to the process attachment. We select the data that we have search for polarity earlier and the exploratory entry section. We have data that is output mobile game, and then we use the set role operator, edit in the set role parameter section. We select polarity for the attribute name and label for the target role. And then we add operator. We use the nominal operator to text, select a subset for attribute filter tag. Okay, next we add an operator. We use the operator process document from the data. In the parameter process document from the data session, we use a tf.idf for vector creation. In this session as well, we need to double click and in the process document from this data, we use a tokenize system, porter, filter stop word, and transform as cases. After that, we add the cross validation operator. In this operator, we double click and then it's divided into two process attachment boxes, one training and one testing. So in this part of the testing, we put all the education tree model, and in this test in the training session, we put the operator, supply model, and performance. After finishing everything, we running the process. We will get a percentage accuracy and for the education tree model of 94.33%. Okay, lastly, we need to different percentage accuracy model. So we need to change the model in the operator part of the model. In the operator part of the regression tree model, we change it to the naive Bayes model and we run the process. And we will get a percentage accuracy for the naive Bayes model, which is 84.50%. So the process for the data set testing is complete.
This is the percentage accuracy result for both dataset. For information, the percentage set for these two dataset is different. So, for the training dataset, the percentage accuracy must exceed 80%, and for the testing dataset, it must exceed 65%. For the training dataset, the percentage accuracy for the naive Bayes model is 84.50%, while the decision tree model is 94.33%. For the testing dataset, the percentage accuracy for the naive Bayes model is 62.75%, while the decision tree model is 79.50%. After we get the result of percentage accuracy for both dataset, which is training and testing, we need to compare these two datasets in order to identify which model is better. So the conclusion we can conclude is the best model is the decision tree model because it exceeds the percentage set by training and testing.